So yeah, thank you for coming to this Agilysis webinar where I'm going to be presenting the result of our analysis on the impact of the introduction of 20 miles per hour across the majority of urban roads in Wales, which happened last month. My name is Richard Owen. I'm the Agilysis CEO. And I led the research here. So hopefully talk you through the various steps that we took along the project. Should take 20 to 30 minutes for me to go through some of this, and then we've got an opportunity for Q&A. So in terms of how the webinar is going to work. So you will have noticed already that the webinar will be recorded and it'll also be available via our YouTube channel. That's where we put all of our webinars and other content that we've done. So yeah, a lot of our historic data and webinars is available there for you to have a look at. If you do have any comments or questions you'd like to be kept private, don't put them in the chat, don't put them in the Q&A. You can contact us directly, and obviously you've got our contact details already, but we'll put them up on the screen at the end too. If you do have any direct questions, and you can find the Q&A button, so that's the one at the top of the screen, depending on which version of Teams you're using, whether you're in an app or a browser or a phone or something like that, try and use the Q&A one, because that just makes it a lot easier for us to sort out the questions from the general chat. In terms of those questions, I'm going to be helped by Steve, who's on the call here too. So yeah, if you put the Q&A in there, then he'll read them out, and then hopefully I'll be able to provide an answer. In terms of the subjects that you want to put in there, obviously it'd be great if we can keep it as much to the general topic of this webinar as possible. If there are broader questions about impacts of 20 mile per hour, I'll certainly do my best to answer those though. There's also that chat as well, and this is something that I've definitely noticed on a lot of webinars recently, is that people really love using the chat option to talk to each other while the webinar is happening. So yes, carry on doing that. I'm going to ignore it because obviously I'll be delivering the webinar itself. If there is anything that comes up there that's more of a comment, Steve and I'll have a look through those. We might be able to pull some of them into the end of the question. Into the end of the webinar, or we can come back to you via email as well. But yeah, you can always contact us if you've got any questions too. So yeah, please do keep it polite in the chat. I'm sure everybody's got a lot of opinions of 20 mile per hour and the impact of it. I've seen the list of the people that are here, and it's great to see so many people from a lot of different organizations, lots of different countries as well, coming here to attend this one, and a lot of familiar faces, I'm sure. So what am I going to talk about today? So the principal focus will be on the research we undertook, but I'm going to kick off a little bit with a review of existing evidence of 20 miles per hour. I'm going to lead a discussion, obviously, with some Q&A from you guys on how we evaluate and understand the impact on vehicle speeds. You know, that's been a focus for a lot of my career, analysing vehicle speed data. And as you'll be able to see, I'm going to talk a lot about the different options that are available there, including some of those new technologies. Something else that I'll cover as well at the end is how we get a better picture of journey experience. This was something that I thought would be quite critical in this research, which is to understand what people's real driven experiences are. You know, what is it like if you're traveling along a typical route, if you're going to school, or you're going to work, or you're going shopping or something like that? What does that look like, rather than just focusing on speed values, individual automated traffic counterpoints, etc. Then we're going to think about lessons for future schemes in the UK and other countries, perhaps, and how this kind of analysis could be used elsewhere. And then Q&A, open discussion at the end. So I'm sure many of you do know about Agilysis and who we are. We are independent road safety and transport data specialists. And this is something I do need to make clear. We're not paid or commissioned to carry out this research. This was something that we saw as a clear opportunity to try and shed some light on something that we knew was going to be having a big impact on people's lives. And it's something that we saw as an opportunity because of access to data. And I'll talk about that in more detail. detail. So, we've got no dice in this game on the 20-mile-per-hour change in Wales. We do have lots of clients from public, private, and third sector. We've got some examples there, some examples of some of the awards that we've won over the years. We do have significant experience in working with vehicle GPS data, which is the data source that we've used here. And we've recently become partners with TomTom, which of course enabled us to do this rapid analysis. We do lots and lots of other work, and I'm sure many of you are aware of the other things that we do in terms of consultancy for road safety policy, strategy, management, those kinds of things. So why did we carry out this research? Well, it was all because of the decision that the Welsh Government made to change the default urban speed limit, so on restricted roads, to 20 miles per hour from 30 miles per hour. Doesn't mean that it's a blanket approach. There's lots of roads that remain at 30 miles an hour or even higher speeds as well. And I'll come on to those in a moment too. It is, however, the largest scale change ever seen in the UK. If you look at maps of where 20 miles per hour are, you can see that actually huge swathes of London are 20 miles per hour now, but that's taken place over almost a decade. This overnight change, as it was certainly the largest scale that we've ever seen in the UK. So there was that opportunity because there's this really important thing happening in road safety, but there was also the opportunity for us to use new data sources, which we thought would be really good in measuring that immediate impact on traffic speed. So, all these things coming together that gave us the opportunity to carry out this kind of work. So let's just have a quick look back and what evidence is already there. So this is not a comprehensive review of all of the evidence on 20 miles per hour. I've largely focused on what's happened in terms of changes in speeds, not looking at casualty analysis or anything like that. But there's a couple of reports that I wanted to mention here that have got different pictures of what's happening in terms of vehicle speeds. So this report here that was published in 2018, commissioned by the Department for Transport, actually the work began in 2014, which was aimed to look at the effectiveness of 20 miles per hour. Now, the report itself contains lots of different measures of effectiveness. It had some surveys of what people thought about the roads and whether they thought that people were changing their speeds, etc. The figures that I put up on here just relate to the observed change in vehicle speeds on there. So yeah, this was published 5 years ago now, based on 12 case studies. So, evidence from well over a decade ago now. And these were areas where, there'd previously been a 30-mile-per-hour limit. So I remember when this report came out that I was quite surprised by the stats that were included in there. So it mentions that 0.7 miles per hour in residential areas, 0.9 miles per hour in city centre areas. So, going from 30 to 20 in these 12 different areas didn't appear to have a very big impact on vehicle speeds. One thing that it did show, though, is that the faster drivers have reduced their speeds a little bit more. But, you think about going from 30 to 20 in most people's minds, and certainly in drivers' minds, they might have expected to see much bigger reductions there. But there has been other research that's come out since then. So this is a paper that was published that looked at what happened in Scottish borders. And here it detected much larger changes in vehicle speeds. So there, the average reduction was 3.1 miles per hour shortly after the introduction of the 20 mile per hour limit. So, much, much bigger than we saw in that Atkins study. Again, it showed that there was a bigger reduction in vehicle speeds where there were already, higher pre-change speeds. So, wherever speeds were above 30 miles per hour on those roads before the change, they were seeing a greater reduction in speeds of 5.4 miles an hour. Obviously, that means that compliance would still not be with the 20 limit. But there's an interesting pattern going on here between those two different reports. And many of us who work in road safety, who read these reports, have been discussing this and saying, well, what is the figure that's important? How can this be used to provide guidance to local authorities on the potential impact of introducing 20 miles per hour? We've done our own analysis as well. So yeah, we were commissioned by Kent County Council in 2020. I think the webinar that we did lasted about an hour on this, is still available on the YouTube channel. So you can see in much more detail what we did there. But again, we used data and information on an area-wide basis. So you can just see a little bit of a map in the background there that showed changes in vehicle speeds. And we saw in the two different locations that we analysed there, one 3 mile per hour drop, one 0.9 miles per hour drop. Again, so there's that range of change in vehicle speeds in the data. Now, within that report, there was the different nature of roads in different communities, and we didn't look at changes on high speed roads, but there's some evidence out there that says that actually we need to know a little bit more about what happens when we simply change speed limits on individual roads. So that's a bit of the background to it. So what was it that we planned to do? So I mentioned that we needed data to do this. So it's absolutely critical that we had two pieces of information. And the first one was about roads where the speed limit was changing. Because it's not a blanket approach, not all urban roads are changing to 20 miles per hour. You needed to only analyse the impact on the roads where the vehicle speeds were changing. Now, fortunately, this information is available and published on the Data Map Wales website, which is a really great resource. You can click on the map, you can zoom in, you can change different layers, see which ones are changing, which ones are remaining the same. You can also, and this is critical to us as well, download those maps as well in a GIS format. And that's really useful for the analysis that we're doing. So we used that and we checked that against two other sources of data on 30 miles per hour. So that included the data from speedmap.co.uk. So that's the almost de facto national map of speed limits. Many local authorities have access to this. It feeds into Ordnance Survey data. It's used by sat-nav companies, etc. So yeah, that's one almost definitive source of vehicle speeds. And of course, that's been updated now using this information from Wales, but also TomTom within their map data, and you'll see that on the examples in a moment, have information about vehicle speed. So we really did check to make sure that the roads that we were going to be analysing were the ones that were going to be changing to 20. So we didn't want to measure speeds on the ones that were remaining at 30, because that would throw out the analysis. So the other piece of data that we needed was information about current speeds. So I mentioned that we've been looking at GPS data for some time. Here's a screenshot from our speed compliance tool. So this one here, that map with the dark background, is showing you differences between speed limits and vehicle speeds. So this one happens to show Lancaster, and it's showing speeds where they're above the speed limit in red. You can hopefully just about see those there, and the ones where they're below the speed limit in green. And I've got a link through to that in the presentation too. Now, while this is a really great resource, and we've got several dozen people that are using this kind of data across the UK, it's only annual data. It's only provided for a whole year. So if you want to measure a change that happened other than on the 1st of April, you need to use another data source, which is where TomTom comes in. So we've been working with TomTom for about 6 months now, talking for even longer than that, actually, about what kind of data they have and they have access to. So we're really happy to be working with them at the moment. Been working with them on a couple of projects, and they effectively donated the data free of charge to this project, which was really great because it enabled us to do this work at no cost, other than the time that we had to put into doing the analysis, of course. So this is an example of roads in Wrexham, and you can see various traffic speeds on that map there. So there's an interactive platform that we access, and then we choose the areas that we want to look at, download that data, and you can customize it in so many different ways. So yeah, it enables us to do this bespoke analysis of traffic data in UK roads. Actually, they've got data in 70 odd different countries around the world as well, and that's something else that we're looking into, whether this can be used outside of the UK to measure, impacts on speeds, but also just what are observed speeds on roads around the world, because we know that that's really important in terms of managing road safety. Now, the most important thing, certainly in the UK, is making sure that we've got access to historic data. It's not just the last year, it's up to 10 years worth of data. And this effectively gives us, a traffic time machine. It means we can go back in time, even if, you installed a project 5, 6, 7 years ago, something like that. You can still go and have a look at before and after speeds within the data. So you don't need to have, put out those manual traffic surveys in advance and then manual traffic surveys after you've made the change as well. You can go and do this kind of analysis with some of the limitations that I'll talk about later. But yeah, you can go and do that anytime in the past if you'd like to do that. So where we have used this data already, so we did a project that was looking at traffic congestion. There's an example here. So we've got the hyperlink there. Oh, yeah, of course, we'll send out copies of the slides to all of you as well. This is an example on our website, and it allows us to look at the richness of the data that's available, including information on probe counts, which is the number of vehicles that are detected in the data, as well as vehicle speeds at different times of day and different distributions of it. So just talking a little bit about the data source. Now, I know there's a lot of people here that are familiar with GPS vehicle data. We've certainly run a number of webinars on it, and I talk quite extensively about it whenever I get to meet people in person, of course. The way that this works is it uses connected vehicle data. Now, many of you will be driving connected vehicles. They're usually the ones that have got the built-in sat navs that are giving you the instant traffic alerts. They're fitted with that 4G SIM card, maybe even 5G SIM card on newer vehicles, that's going to be transmitting information into the vehicle, but also transmitting vehicle data back. So I think about 75% of vehicles sold in the UK last year were a connected vehicle. Almost all are going to be connected by 2025. So there's this increasing picture of vehicle data that's being built up by people like TomTom. Lots of other suppliers have this kind of data too. The great thing about TomTom is they do aggregate it from multiple different vehicle makes and models. Having this data available means that you can kind of see what traffic patterns and vehicle speeds are on the road network without having to go and do those surveys. So if anybody does want to know a little bit more about connected vehicle data, we wrote a white paper on that earlier in the year, and I recommend that you do have a look at that. So back to the research methodology then. So we couldn't analyze all the roads. It would have been great if I'd analysed the changes in speeds on all of the roads in Wales, but that's quite a lot of roads. I haven't got the precise figure in front of me. So we needed to do something that was reasonable in the time. So we picked 10 because that's a good number, isn't it? 10 towns and cities with a reasonable geographic distribution. I've got some understanding of the geography of Wales. So looked at some larger towns and cities, but then some smaller towns as well. And then had a look at the roads that we knew because of the data being published on the Data Wales website, which ones were changing from 20 to 20 from 30. And our aim was to measure the average speed on the individual road sections. We can't see what the speeds were of the individual vehicles because all of that's subject to data privacy rules, of course, but because it's aggregated on individual road sections, we can see what's happening there. So that's what we did. We looked at the individual road sections and detected those changes. So we, in terms of the sample that we drew, we came across almost 500 kilometers worth of roads in the original sample, but then we did narrow that down a little bit. In terms of the research methodology, the way that we worked, we were trying to detect the changes that happened before and after the speed limit. Now, I decided to choose a 5-day period. I was going to choose weekdays rather than weekends. That's Part of that's because we wanted to look at the normal Monday to Friday traffic and take out the effect of any weekends in there. We could have done that if we wanted to. It meant we'd have had to wait a couple more days to publish the report, though. We also looked at a 6 a.m. to a 6 p.m. period because that's when most vehicles are traveling on the roads. We could have looked at a 24-hour period if we wanted to. You know, lots of different ways that the data could have been cut up, but this is the way that we chose to do it within our analysis. Now, we wanted to make sure that there was enough data. So for individual road sections, and I'll show you one in a moment, we made sure that there were at least 100 vehicles for each road segment in the sample sizes in both periods. So in the week before and in the week after. So yeah, removed any roads that might have had, you know, just only a couple of dozen in there. We also chose to measure the 50th percentile speed, which is also known as the median. Now, for those of you that did GCSE statistics, I'm sure you'll know what the difference is between median and average. If you don't, there's a really good YouTube link that I've put on there. And obviously you can go and have a look at that one later. So that's from the Statistics Authority of Ireland. They do a really good example, and I'm definitely going to show it to my teenager that's doing GCSE statistics when he gets home tonight. So in statistics, there's various measures that allow us to represent the characteristics of a group. So for us, this group's vehicles, and the characteristic is the vehicle road along those individual sections. So one of the measures that you're probably used to, the most commonly used one, is the arithmetic mean average. You know, we talk about average speeds. And the mean is the sum of the characteristics, i.e. the individual vehicle speeds in that group, divided by the number in that group. But if you want to describe the central tendency of the group, the mean's not always the most appropriate measure. So unless you've got a perfectly equal distribution in the sample, so you know you've got that perfectly shaped bell curve, you're probably best off using the median instead. So if the group contains some elements with exceptionally high speeds or exceptionally low speeds, perhaps, then that will push the arithmetic mean well above or below the central tendency of that group. So yeah, the median is perhaps the appropriate statistical measure, and actually it's the one that was used in the DFT Atkins report that I mentioned earlier. So here, you know, you can see it within the data as the 50th percentile. So if I show you here, here's an individual road section. So this is the data as it comes out of TomTom for us. So you can see there at the top, just about in that little roundel, that it was a 30-mile-per-hour road. And then you've got information about this individual link here. So what I've done is I've highlighted in the orange box the average speed there, 18.1 miles an hour, 91 miles an hour. But the median speed is 20.51. So lifted slightly higher, you know, almost 2 miles per hour higher than the average speed. And that's almost certainly due to the distribution of the traffic. There will have been some congested vehicle traffic on there. So one of the ways that you can get rid of that congested data is to only look at the 50th percentile speed in there. And actually, this is a road that wasn't included in the analysis. Those of you with good eyesight will have noticed that the sample size was only 98 on this individual link. So we wouldn't have included that data on there. So even though 98 is actually a pretty good sample for this road, yeah, we made sure that we only went with the roads that had the highest volumes. We could have done it across all of them. It has shifted the statistics very slightly, I suspect, not too much, but we wanted to make sure it was as robust as possible. So a little bit more on the methodology before we start to have a look at the stats and then get towards some of the chat. The way that it worked, we ordered the data on those 2 Saturday mornings immediately after those periods, imported the data into our GIS software, processed it, matched it, and then yeah, chucked it all out into Excel for analysis, because Excel is still, you know, a really great analytical tool for doing this. You didn't need to have any advanced statistical platforms or knowledge in there. It's all done with a few simple Excel calculations. Yeah, as I mentioned, we excluded those low sample roads. But one thing that we did do to take account of sample was to do a weighted average based on sample size. So you can see the calculation that we did at the bottom there. So even though we'd already excluded those low sample roads, we wanted to make sure that if you had roads that had 10,000 vehicles going down it in a week, the vehicle speeds on those roads had greater prominence in the analysis than the ones that were lower speeds. So this is explained in much more detail in the report. My colleague Craig helped me write this section. But yeah, please go and have a look at the report on our website. So I've talked about caveats, but we've got almost 60 million vehicle movements in the sample. So that's 60 million vehicles that went from point A to point B on one of those individual roads, as you saw earlier. That's a lot of data to be analyzing. And it's great that we can still do that in such a tool as Microsoft Excel. So here we go. These are the results. So I'm sure many of you have read the report already, but this is the data that we had on pre-implementation speeds. So those weighted average median speeds were 22.7 miles per hour pre-installation. That means that on the roads that we analysed, and on, I would say, typical 30 mile an hour roads in Wales, people weren't travelling at 30 miles an hour. You're not traveling consistently at 30 miles an hour. You're speeding up, you're slowing down. So people's journey experience was not 30. And I think this is quite important when we're listening to arguments about, the impact on people's journeys, on people's livelihoods, etc. There's a perception that I think is incorrect about the speeds that people were traveling at. This is the evidence. This is showing that you weren't typically on a typical journey doing 30 miles per hour before. You were usually doing 22.7. Now, if I'd analysed speeds at midnight, hey, could have been higher than that, but that's not a typical journey, and that's what we wanted to measure in this analysis. So what happened in the week after? We saw that drop in vehicle speeds. So you can see that we went from 22.7 down to 19.8 miles per hour. And the shift in the distribution of those individual road segments based on those average speeds in there was quite dramatic. You went from a slightly flatter curve and distribution to one that was much closer together. So what we're getting is much more consistent speeds across the road network. And I think this is really important too. Okay. Let's move on then a little bit more. So I have included some information on limitations, because I think it's really, really important when we carry out research like this that we're open and honest about where the data comes from, the methodology that we use, the different sources, but also some of the limitations in there. So, I've talked about the fact that this is GPS data, which means that not everybody's driving a connected car. Not everybody's driving a connected car that's reporting data back to TomTom. So we've only got 20% of vehicles, but we've got 20% of vehicles. I mean, that's still a really large sample size. We don't have any motorcycles in there. So that is one limitation. So we've got a small percentage of traffic that might display different speed profiles that's not included in the data. It might be a few years before we have connected motorbikes that are providing information into this sample. Also, it doesn't show the peak speeds along a longer road section. So the one that I showed earlier was okay. It was only 100 meters long or something like that. So you wouldn't expect the speed distribution on that road to be very different from the average speed along that route. But you can imagine on some routes, and certainly in rural areas, perhaps, you might get some peaks along those individual routes. And it doesn't show those extreme values for individual drivers because, it's that anonymized data. I can't tell you precisely, how many drivers, drove at 30 miles per hour still, despite the fact that it was 20. You can estimate some of that by looking at the data, but you can't tell for individual people. We could have analyzed the 85th percentile data that was in there. So again, you saw that on the screenshot too, just didn't have time in the analysis to do that. And as I've already mentioned, speeds will be higher at night. It might be higher at weekends. Whether we'd analyze that, would that have skewed the figures a bit? I think because of the sample size and the way that we did the weighted average, it wouldn't really have made a lot of difference on there, but we chose not to do that. Could it be rerun in a different way? Could you do it at weekends? So, I've mentioned that it was a small sample of roads. 490 kilometers is still a pretty large sample. If you think of how many traffic surveys you'd need to put in place to measure speeds consistently along that road, that would be really quite a lot. But, that's it still didn't include all the towns. And of course, longer term monitoring would provide a much richer picture of trends over time. We can have a look at data today, for example, to see what was happening in there. One of the key limitations, though, is that it does include that congested traffic, and that's something that I've seen people mention. They've said that, oh, well, it's not realistic because it includes congested traffic. I'd argue that it is actually much more realistic because it includes congested traffic. But historically within the sector, we've looked at a free flow speed. So free flow speed looks at the maximum speeds that people would be choosing to travel at, so the maximum average speeds that people would be choosing to travel at. So I've got a couple of slides based on this one. There are statistics that the DFT in the UK provide on vehicle speeds. You can click on this link and read all about how they do that. Now, they use free flow speeds at locations where external factors won't restrict behaviour. They also make sure that there's a minimum vehicle headway of 2 seconds, so a gap between vehicle of 2 seconds in there. So that's the way that they do it. As I've said, you could just look at nighttime speeds, but is that really representative of what's happening on the roads? Or look at those 85th percentiles. Now, interestingly, the Department for Transport in the last couple of years in their statistical releases have said that the data that they publish on 20 miles per hour is not truly representative of the majority of roads that are 20. So their figures tend to be much, much higher. I did find some analysis. So here's a publication that looked at what headway and free flow speeds look like. So this was a study in the Czech Republic. They compared free flow speeds with all observed speeds, so similar to the kind of data that we used. And that found that on their 90 km/h rural roads, that there was about a 4 kmh difference between the two different speed values. So yeah, we'd expect to see some slightly higher free flow speeds, but they're not totally unrepresentative. And of course, if they're consistent between all the individual roads and between the analysis periods, it's the change that we've been measuring in this report. It's not the absolute vehicle speed. And I think there's still a lot of debate to be had about which is the most valuable speed. Is it the one that's truly observed by vehicles that are driving on our roads? Or is it this statistical creation that we've come up with of free flow traffic speeds? Now, we can still analyze free flow speed using TomTom data. So what you've got is 3 examples that I'm going to show on the screen here that you can actually go and have a look at, because it's a tool that's embedded on our website. We've produced this for the whole of Banbury, which is of course where we're based. So yeah, you can see in these, hopefully, if you have a look up at the top corner here, you can see that we've got some average speeds and then we've got some median speeds. But what we've also done is that we've calculated the average free flow speed at the bottom here too. So the way that we've done that, I'll get my laser pointer out. So what we've got here is we've had a look at the different distributions in vehicle speeds here. So you can see at this junction, which is near some traffic lights, that you've got some queuing traffic here. So we've captured this queuing traffic at the bottom there, but then you've got the more free flowing speeds throughout the day, and you can use these statistical techniques to analyze that percentage of free flowing speed. So here's another road, which is a bit towards more the outskirts, and you can see, yeah, much more normal distribution around the central point here. And so there's not very much congested traffic. So we've got, I think, 87% free flowing traffic happening along this link. And then we can find another one here, and this has got another distribution. So this was a bit of a dromedary distribution here, 2 humps there. Yeah, so we've got a bigger peak there of congested speeds, and then some uncongested speeds at the top there. So I think what we're showing here is that there's amazing opportunity with the data that's out there with some more advanced techniques to try and understand what all these different speed profiles look like. Now, of course, this is only important to maybe a small number of you on the call, but what I wanted to show is that, we are taking into consideration all of the different things that could be impacting on the analysis that we produced. The final thing that I wanted to talk about was journey experience. Because I do think this is really important, especially when you're making a change across a population. We want to look at what the real life change was. So what we did is we had a look at a couple of routes. So one in one in Cardiff and then one in Wrexham, and had a look at these. I think they're about 1.5 mile long routes, and then we had a look at what the journey time was likely to be along those routes. So excuse the y-axis here, where it's gone slightly wrong as I've imported it. What we're showing here is changes in speeds. So all of the roads saw increase in speeds, increase in travel times. Sorry. So obviously we saw that there were changes in vehicle speeds, which we saw in the overall statistics. But what we were looking is changing it in those travel times. So yeah, we saw that there was an increase in travel time, sometimes up to 60 seconds for one of these individual routes, sometimes only 45 seconds. And I think it was reflecting the fact that on some sections of road, there was a much greater reduction on speed. And on others where perhaps speeds were already around 20 miles per hour, you wouldn't expect the introduction of a 20-mile-an-hour limit to have much of an impact there. And actually, this next slide does show this one a little bit better. So on the right-hand side, you've got journey speeds before the change. So mainly red, so moving up in excess of 26 miles an hour, 29 miles an hour on that individual section of road. But then at the bottom, we've got some blue speeds, so below 20. And then on the left-hand side, we show what's happened after the 20 implementation. So obviously speeds haven't changed very much where speeds were already quite low, but what we've seen is the reduction in speeds on those roads where speeds were previously higher. So yeah, two different ways of analysing the data, and I think both are valid approaches. So in conclusion then, I'd say that these new data sources offer a great opportunity for us to have a look at this data really, really quickly, or even historically, back in the past, if you wanted to see what had happened because of an individual event, whether that's a change in a speed limit, it could be introduction of a new engineering measures, it could have been, I mean, you could almost look at the impact of individual collisions on traffic delays and things like that, because you can order down to the nearest 15 minutes on this data. I mean, that would be really fascinating to have a look at what happens in some of that. We did see that drivers responded immediately with this 2.9 miles per hour reduction, even though it was a signed only limit. So that was really interesting to see how people change their speeds. I was surprised to see it that high. I think just because of the data that we'd seen previously on some of the other research, it wasn't conclusive. But that 2.9 miles per hour is very similar to the one that we saw in Scottish borders, but it's definitely a lot higher than the current knowledge that's within the DFT report. But we did see there was a narrow distribution in speed values for roads in the sample area. So there are more opportunities, I think. We could have looked at those 85th percentiles. We could just analyze the roads where we saw those high speeds remaining. Now, I didn't show them on there, but we've got a map now. We can see the roads that have changed to 20 that aren't showing those big reductions. There's not as many of them, but that evidence is available. How useful is that to authorities who are thinking about what they do to try and achieve better compliance on those small sections of roads? There's further research possible, of course, into the differences between the GPS data and traditional sources. This is where I get my slight data nerd hat on. But yeah, I'd be really interested to look at the different values of those different kinds of data sources, as well as the traditional sources, where you get tubes put out the roads or you put out radars and things like that. How reliable and comparable are they? My spider sense says that I think it's pretty comparable. But of course, there is going to be a longer term analysis, not carried out by us, carried out by the Welsh Government. So those official survey results will come out in the months and years ahead. And of course, that will look at the important information from the casualty data too, because that is, of course, the imperative behind making these changes in vehicles, in speed limits and vehicle speeds, is to make sure that that casualty reduction can be achieved. So we're going to do some Q&A in a moment. So there might be some Q&A there, either that or everybody's fallen asleep or has been engaged in the chat, which you'll find out in a moment. But first, I just wanted to mention that we do have our Joining the Dots conference coming back again for, I think, the 8th year now. I can't remember. It's been a long time, Steve. So that will be at Woburn House in London. So it's a hybrid conference, so you can join online like this, but we do very much like seeing people in person. So yeah, over the coming weeks and months, we'll be announcing speakers as well as our sponsors for that event too. So yeah, I'm not saying that this will be repeated on there, but I think we're definitely going to be looking at lots of novel analysis in the world of road safety. So over to the Q&A, and this is where I come to Steve and I say, are there any questions, Steve?
Yes, there are. Hello, everyone. Just a reminder, if you do have any other questions for Richard, just look out for that Q&A button, which should be on the toolbar, along with all of the others. So we do have a few questions in. So Richard, I'm going to start with just clarification over 40-second change over what distance, asked by Adrian. I think referring to those two routes from the report, sort of what distance were they over?
All right, so yeah, I think there was one that was about 2.4 miles and one that was 2.6 miles. It's included towards the end of the paper that we've published. If it isn't included in there, then I can definitely pull out the raw data and send that through. But yeah, so it was looking at that between about 40 and 60-second change in vehicle speeds. Sorry, in journey times. Sorry, I keep saying that. Journey times.
And so obviously we've published the sample sizes in there, but what sort of percentage or coverage of traffic would that be comparable to?
Yeah, that's a really interesting one. So there's lots of different data suppliers out there. It's not just TomTom. We work with other suppliers' data in the past, and it can sometimes be quite difficult to find out what the sample size is. The one thing that TomTom do that other suppliers haven't always done, as far as I'm aware, is publish those probe counts. So you can see those statistics there, and we use that in our data and in our analysis. They tell you the precise number of individual vehicles that have been monitored passing over that stretch of road in each direction for the time period in the analysis. And actually it's quite good. You can even exclude roads that don't have a high sample size before you even order the data. So you can then use that to try and work out what you think the sample size is. But for that, you need some ground truth data. So in terms of ground truth data, we have a great resource in the UK. I don't know if many of you have seen this, but if you just search on DFT traffic stats or count points, you'll find a website that's got an interactive map that allows you to scroll in and look over thousands of roads in Great Britain, and then look at what the observed traffic counts have been going back well over a decade. So what we can do is we can use that information and say, well, the DFT says that there's 10,000 vehicles on this road every year. We bought a year's worth of data from TomTom that had 2,000 vehicles in that sample for that individual road per day. So therefore, we know that it's about 20%. Now, it goes up and down. There may be some small regional differences, some urban rural ones. We haven't tested that out yet. One thing I would say is wherever we've looked at it, we've come up with reasonably good sample sizes. I've never seen anything less than about 15%, and I've seen them as high as 30%. So I'm going on a central estimate of around 20. There may be some other statistics available. Maybe even TomTom have something on that, but yeah, about 20%.
Right. Okay. You're gonna have to forgive me for this next one because I'm not entirely sure that I understand it. So another one from Adrian. Why is the WS Atkins data so different? And then goes on to ask, Appendix A of the DFT speed assessment tool is also completely different, shows a much lower change. Is now the time for the DFT to change their formula for predicting speed changes?
So that's a big one. Why was the Atkins report different? I don't know why it was different. I can come up with some ideas why it might have been different. I mean, these are early days of 20 miles per hour. Perhaps there was less education within the motoring public about what those speeds were. Perhaps the roads that they chose already had very low speeds. If you already had average speeds of 21, 22 miles per hour, might not have seen as big a reduction. So could have been for those reasons. Yeah, it may be that we're just more accepting of this. Maybe more of us are driving some of these higher tech vehicles that are automatically, pinging warnings at us, telling us to slow down. I know it's not a part of the law that they have to be fitted now, but a lot of more modern vehicles have that speed limit that is brought up on the dashboard. So perhaps there's some changes in vehicle technology that's moving towards it. I'd hope that it's that we have changed as motorists and we recognise the value of those lower speeds now. Maybe somebody else knows. In terms of the DFT's evidence and how they advise authorities on setting speed limits, we do know, thanks to the Plan for Drivers, I think it's called, that was released just before the Tory conference. I'm pretty sure that one came out. Yeah, there's going to be new guidance on setting 20 miles per hour. It may mention discouraging blanket limits or further enhancing consultation. I'm not quite sure what that's going to involve. Obviously there's already guidance and consultation. I would be disappointed if it goes back to that Atkins report, because I do think there's enough evidence now that says that if you just put in 20-mile-per-hour signs, say just because it's still a really big undertaking, and you don't put in any other physical measures, even if it's just lines, extra signage or flashing signs, whatever it is that you do. I think there's good evidence now that the reduction is going to be greater. So I think there is a good case for that to be updated. Whether it will be updated in that direction or another direction, who am I to say?
Next question is sort of, I guess, from a more of a safe system perspective, about linking with enforcement and support between police and local authorities, as sort of any 20 to put in, if you have any sort of perspective on that.
Yeah, I think so. Those of you that know me know that I used to manage a safety camera partnership. Don't know whether that's going to make me any more or less popular. But one thing we did whenever we changed speed limits on roads is that we always had that grace period. We police with consent in this country. I think it is reasonable to put in an amount of time to allow motorists to get used to the limit. Although we did see that they got used to the limit pretty quickly in this. But we do need to make sure that we can encourage, using as many different mechanisms as possible, including enforcement, those that are not following the rest of the average driver, those that are just still continuing to exhibit high vehicle speeds. We need to find ways of getting to those drivers to make them adjust their speeds. It could be that they don't understand what 20 miles per hour means. We've seen a huge increase in the number of speed awareness courses that happen in this country. In order to get people on their speed awareness courses, to educate them, they need to be detected speeding. But I think it does need to be introduced reasonably carefully to make sure that you don't overwhelm back office systems and things like that. So enforcement absolutely has a place on the road network. I think picking off the roads that have got worse compliance issues might be interesting. Are there warning messages that could be put up on screens? Could you just send people warning letters instead? I know that National Highways did that with their REDX schemes. I don't know if they've done it in ULEZ areas as well, things like that, educating people as to what's happening. A little bit similar to Community Speed Watch as well, that we noticed you were speeding through our area, that kind of approach to begin with. But ultimately, we know that speed enforcement is a really good way of getting people to reduce their speeds if they're not going to respond to those other measures.
And what about really interesting question, I think, here from Adrian again, about whether we have seen any differences between changes in speed limits nationally, when it's rolled out nationally, like it is with Wales, or on a local level. So Adrian's mentioned the Scottish borders there in London. Obviously, we've done that Kent work, which was looking at evaluating across 2 towns, and I'm not sure. Is there any difference between the two?
Well, That's really interesting, because Wales could have just done a bit by bit approach. They could have done, we'll do this area, we'll do that area, we'll do that area, but they decided to do it all in one go. Now, I do know that there's other places that are doing it on a step-by-step approach. So, Steve, you'll know that in Oxfordshire, we've got lots of changes in speed limits coming. That's been happening over many, many years. It'd be interesting to look at the impact of those changes over time. I mean, that'd be a great research program to write, to look at those changes historically. Might help answer some of the questions about what historic changes were and why they seem to be better now in the data. But I know that there are other areas. So I know that Cornwall are looking at a program of introducing changes on a step-by-step process over many years. Yeah, no, it's a really interesting one, and I think it's something that the data would allow you to do, to see whether it's that if you just go do it all in one go, that has a much bigger impact than doing on a on almost piecemeal basis.
Next question here, which I'm hoping this means something to you, is do you know what proportion of the sample used ISA?
I don't. However, it's a good point. I hadn't thought of that one, because you would expect that if we're using connected vehicles, they're likely to be more modern vehicles. More modern vehicles are more likely to be having ISA, so intelligent speed assistance, other, or even just popping up and warning people what the speed limit is. So, hey, could be that our sample's very slightly biased. It could be that if we had data on older vehicles that didn't have ISA as technology, that maybe they weren't seeing their speeds reduced further. I think this is why the Welsh government analysis that they're going to be doing using some traditional data sensors, a smaller number of sites, obviously a big enough sample size as well. It'd be interesting to compare those two results together to try and figure out if we've just got a bunch of nicer people, let's say. But yeah, it's good speculation.
Coming up to the last question here from the Q&A. Another one from Cheryl talking about fewer vehicles and benefits to active travel, and asking about how, if there is any research around alternative transport choices and the speeds that they can achieve or can go, and how we might monitor these in the future. So obviously connected vehicle data is cars, vans, trucks. How might we go about monitoring other kinds of vehicles as well?
Yeah, and if we're thinking about bicycles, normally we haven't got any. They haven't got any e-scooters in Wales. But if we're talking about cycling, I wouldn't expect cycling speeds to change as much, because you wouldn't expect them to have been traveling at 30 miles per hour, or even getting up to 30 miles per hour. Listen, Bradley Wiggins is around, I'm sure. So I should say Geraint Thomas is really, as it is Wales. But yeah, there will be some faster cyclists out there. I think the interesting thing would be to look at what's happening in terms of the number of people choosing to cycle, choosing to walk, are they using other active travel means? I know that's something that other analyses have done. That was something that was mentioned within Kent, something that was included in the Atkins report. It'd be great to see that, and I'm sure the Welsh government will be planning to do this on well, looking at people's attitudes towards that, but also directly measuring the changes in the number of people that we see cycling and walking. We have unfortunately had a bit of a drop off in people cycling and walking over the last couple of years. I'm sure many of you will still remember, 2020. When a lot of us chose to use more active travel modes, cycling and walking. We saw a huge increase, I think 40% increase in the number of people cycling, number of miles cycled across the UK. That has dropped off a little bit away from that peak. I think that would be, as well as seeing casualty reduction, one of the key metrics that we want to see in the analysis, or certainly that the Welsh government would like to see within the results.
That's it for the questions. Although I do have one of my own, which is what next? Where do we go with this next, or how might we better use this kind of data in the future?
Yeah, I think It's really interesting. You know, I've got I've got 2 more sessions this week, one with CIHT and one with Road Safe, because people are learning about this, and they want to understand what the potential is, to understand what's happening on the roads and understand the critical role of vehicle speeds in road safety. So I think there's a lot of people that want to understand what the benefit of this is. I have had a few conversations with local authorities that are interested in replacing their existing survey technology with this kind of thing. But the other thing as well with that as well is it's opening up possibilities for people. They're saying, well, yeah, previously I might have just looked at 10 or 20 roads or something like that. Now I can have a look at entire towns or get out to villages where I possibly wouldn't have done it because it's quite a small section of road. Gives you a much more widespread view of traffic speeds. And it's not just for roads where you've made a change as well, or going to make a change. You know, it enables you to, you know, have a look at what vehicle speeds are at the moment. And if you're planning to implement lower speeds, so whether that is 20, whether you're thinking about reducing national speed limit roads down to 50 miles per hour, etc., you can see in much more detail what traveled speeds are at the moment, and then think about what the impact might be when you make those changes. So, you know, even if you just took that 2.9 mile per hour change and use that as a blanket, if you take that and then link that to the existing speed on the road, that would be fascinating, because you could then say, and these are the roads where we may need to do something that's not just sign based. You know, there are lots of different ways of controlling vehicle speeds. We've already talked about enforcement. Physical measures are more expensive. Sometimes they may just be required. Obviously, we want roads to be self-explaining to traffic and motorists to understand why they need to travel at that speed limit. But sometimes you need other nudges and interventions along the way. And yet using this kind of data both before and after, I think is really useful. Okay, well, if that is everything and nothing else has come up, I'm going to have great fun wading through the comments in chat that I've seen popping up, and trying to ignore them as I'm going along. Thank you for attending the webinar, everybody. Incredible turnout here. I saw we were peaking well over 160 people, which is the biggest attendance we've had for probably about a year, I think, on these. If you've got any questions, drop me a line. If you want to talk about the data, you can see I love talking about the data. There's a whole bunch of professionals that have been on here talking about it as well. I'm sure they can help you if you want to know more about 20 miles per hour or vehicle traffic data and all those kinds of things. So yes, thanks for turning up, everybody, and I hope to see you all again another Agilysis webinar, or even in person at Joining the Dots next year. Thank you very much, and thanks to you too, Steve.